The first I'm going to talk about solutions or problems where you have to draw up a certain amount of medication in a syringe. The second video will add the complication of weight-based medications. And finally, the third video is going to talk about drip rates. Now, Chris talks about the master formula, and the benefit of the master formula is this is the only formula that you have to memorize in order to do all these calculations. The formula is desired dose times the weight of the patient in kilograms times the drip set that you're using divided by the concentration of the medication you're drawing up times the time you're administering it. And you use as much of this formula as you need for your particular problem, and then you can just ignore the rest of it. So think of this formula as dd times w times ds divided by c times t, which you can memorize as Dunkin' Donuts was dropping sugar over their coffee and tea. So let's start with the first problem. You have a patient who's presenting with an exacerbation of congestive heart failure. After the administration of nitroglycerin, you decide to give the patient furosemide at a dose that is twice that of his daily dose. The patient normally takes 40 milligrams of furosemide daily. How many milligrams will you give to your patient, and how many milliliters will you draw up from the vial? And I'll just point out that furosemide comes in vials that has 100 milligrams and 10 milliliters. So let's go over what we just discussed. The patient normally takes 40 milligrams of furosemide, and we want to give twice that amount for this administration, so that's 80 milligrams. Okay, this is the desired dose. And the concentration for the medication of furosemide comes in a vial that has 100 milligrams in 10 milliliters. This is the concentration. And we'll just put that in the formula, dd divided by c. So the 80 milligrams divided by 100 milligrams over 10 milliliters. Okay, we ignore the rest of the formula. I would recommend when you do these calculations, you reduce the concentration down to a standard concentration level where you're doing the concentration of the drug over milliliters. In this case, I divided both of these sides by 10, so it's 10 milligrams in 1 milliliter. And finally, for the last step, we just divide 10 into 80. That's 8. And the milligrams cross off here. And when you do the double division for the milliliters, you end up with milliliters. That's your final answer. Let's do the next problem. All right, you're treating a patient who has a possible broken hip, and you wish to provide that patient with some pain relief. You decide the best course of action would be to deliver 75 micrograms of fentanyl. How many milliliters will you deliver? All right, fentanyl comes in Carpujet. It's a sort of a prepackaged syringe that has 100 micrograms in 2 milliliters. So let's write this out. The medication, the desired dose, is the 75 micrograms. And the concentration of the medication is 100 micrograms in 2 mLs. So going back to the formula, the dd divided by c, we have 75 micrograms divided by the 100 micrograms in 2 mLs equals 75. Here I'm going to divide the 2 into both sides, so I have 50 micrograms divided by 1 ml. And to do the calculation, the due to division, I'll write that down here. 50 into 75 it goes once. Let's give myself some more room. And here I have 250. 50 into the 250 is 1.5. So the final answer, 1.5 mLs. Again, the micrograms cross off here, and the mLs come up to the top when you do the division. 1.5 mLs. Next problem. Okay, this patient that we're dealing with, this patient is not tolerating the situation very well, and you decide that she would be better served to forget the entire ordeal. You decide that 2 milligrams of Versed would be in order. How many milliliters will you draw up and deliver to your patient? Well, the desired dose is 2 milligrams of Versed. And Versed comes in containers, vials, that have 5 milligrams in 5 milliliters. So, DD divided by C, 2 milligrams over 5 milligrams, 5 mLs equals 2 milligrams over 1 milligram per ml. And this one works out pretty easy. We have 2 milliliters is the answer. Next problem. All right, this patient that we're dealing with, they start to break out in hives, and you wish to administer some diphenhydramine at the dose of 25 milligrams. How many milliliters will you deliver? The desired dose is 25 milligrams. And the concentration, diphenhydramine, comes in bottles or vials that have 50 milligrams in 1 milliliter. So doing the DD divided by C, 25 milligrams over 50 milligrams equals, in this case, we're already in the most reduced formula. We're in the standard concentration. We have to do the division, 50 into 25. Let me do that up here. 50 divided into 25. All right. Well, 50 goes into 25 0 times. And let's bring down. And 50 goes into 250 5 times. So our final answer is 0.5 milliliters. Next problem. I think we're still dealing with the same patient on this one, the next one. Here we go. Yep. The same patient is really having problems that you believe are associated with the administration of Versed. So you decide to reverse its effect by administering some Romazicon. The dose that you want to give is 0.2 milligrams. How many milliliters will you deliver? Well, Romazicon comes in vials that are 1 milligram in 10 mLs. Let's see. So our desired dose, we said, is 0.2 milligrams. And the concentration is 1 milligram in 10 mLs. Going to the master formula, we have 0.2 milligrams divided by 1 milligram in 10 mLs. All right, that's going to be 0.2 milligrams. And if I divide 10 by both sides, I get 0.1 milligrams divided by the ml. And in this case, I wanted to divide the 0.1 into the 0.2. Well, Some people may see right away that's 2 milliliters would be the answer. Let me do the division over here just in case that's a spot where people are getting confused. 0.1, okay, into 0.2. And when you do that, you move the decimal point over 1 whenever you have this decimal point out here in the first number, and you move it over here, so the decimal point now goes here. And we're dividing 1 into 2. That's 2. So the answer is 2 milliliters. Next problem. Okay, our problems still abound with this poor patient. And we're thinking now that maybe it's the fentanyl that's causing all the problems, and you decide to administer 0.4 milligrams of naloxone. How many milliliters will you deliver? All right, the desired dose is the 0.4 milligrams of naloxone, and the concentration, naloxone comes in vials that have 4 milligrams and 10 mLs. So going back to the desired dose divided by concentration, we have 0.4 milligrams divided by 4 milligrams, 10 mLs. I'm going to divide 10 into both of these numbers over here so that we have the 0.4 milligrams divided by 0.4 milligrams in 1 ml, which is equal to 1 ml. You're dividing 0.4 into 0.4. 2 more problems for this class, for this type of problem. Let's see. You are treating a patient who has a severe exposure to organophosphates, and your protocol dictates that 7 milligrams of atropine be delivered to your patient. How many milliliters are necessary? So the desired dose is 7 milligrams of atropine. And atropine comes in containers. I'll just say I'm looking at pictures of the drugs here, so that's how I know this. The atropine comes in concentrations of 8 milligrams of 20 and 20 mLs. And we go to the formula. Desired dose over 8 milligrams, 20 mLs. Just in looking at this, you want to give 7, you want to give almost, the vial has 8 milligrams and you want to give 7 of it, so you're giving almost the entire vial. So our final answer when we come up with it, we want to see we're giving something almost very close to the 20 mLs. But let's continue. 7 milligrams. In this case, we want to divide 20 into 8. I'll do that over here. Okay, 20 doesn't go into 8. That's 0. But 20 does go into 80. It goes 4 times. So we have 0.4 milligrams per milliliters. Okay. Now in the next part of the calculation, we want to divide 0.4 into 7. Let me write that down here. I'll give myself some more room. Okay. The 0.4 divided into the 7. All right. Again, when we move this over, we move the decimal point over 1. Move it over the same way. 4 goes into 7 once. So put down 4. That creates 30. 4 goes into 30 7 times. Okay. And 4 goes into 25. And that is actually our answer right there. The answer is 17.5 mLs. And remember, we were discussing we want to give almost the entire vial, and you see 17.5 is pretty much all of the 20. And our last problem in this class, in this type of question. Let's see. All right, you have a patient who needs 20 milligrams of ketorolac, which I read is a painkiller. And how many milliliters will you draw up? All right, so the ketorolac comes in 50 milligrams and 2 mLs. Let's write out everything we have. Desired dose is 20 milligrams. And the concentration is 50 milligrams in 2 mLs. Let's write out the formula. 20 milligrams, 50 milligrams, 2 mLs. Doing the division here by 2 on the bottom, 20 milligrams over 25 milligrams, 1 ml. I want to divide the 25 into 20 at this point. 20. Okay. Well, 25 doesn't go into 20. I'll put an extra 0 here on the decimal point, but 25 does go into 208 times. And that is the answer, 0.8 milliliters. So that's it for this class of problems. The thing I would suggest is just write down everything that you have, follow the steps step by step, just brute force it, and in the end you'll come up with the answer. And sometimes you can even just look at the final answer that you have versus the information that you started out with, and it gives you some kind of answer whether it makes sense or not. For example, here 20 milligrams is a little less than half of the total amount that's in the bottle. So our final answer, you would hope, is a little less than half of what's in the entire bottle, the final liters that you want to give. So 0.8 is a little less than half of 2 milliliters, so this answer makes sense. So that's it. On the next video, I'm going to go through some weight-based calculations, and then on the third video, I'll do some drip rate calculations. Hi, my name is Kirk Fleming. I'm an EMT and paramedic student, and I also have over 30 years experience working as an insurance company mathematician. I thought it would be helpful if I worked through some problems, some med math problems, and just show step by step how you would do the calculations. I'm going to recommend a website called Paramedic Pearls and Pitfalls. It's produced by Chris Johnson, who's a paramedic and paramedic instructor down in Florida. Chris has on his website 20 problems that he routinely gives his students to work through. I'm going to use those as a basis for problems to go through and actually do the calculations. Chris recommends a master formula. It's the desired dose times the patient's weight in kilograms times the drip set being used divided by the concentration of the medication times time. That you can think of as DD times W times DS divided by C times T. Or a mnemonic would be Dunkin' Donuts was dropping sugar over their coffee and tea. The advantage to this formula, it's the only formula that you will need. You memorize this one formula, and then you use the pieces that are presented in your problem. You can ignore the rest of the pieces. That's what I'm going to be using in this video to work through the problems. The first video dealt with drawing up medications in a syringe. This second video deals with adding the weight-based calculations for medications, and the last video is going to deal with drip rates. First, a quick comment on weights. In our class, when we talk about weights, I'll say there's two ways that I've seen people convert pounds to kilograms. And the traditional way, or the more exact way, is to divide by 2.2, and I'll just say that's roughly 73 kilograms. It's not exact. In our class, when we are told to convert weight, we're being instructed to divide by 2. And I can see a couple of advantages to using 2 versus the 2.2. First of all, the 160 that you're being given is an estimate. It's either you're guessing the patient's weight or the patient telling you their weight. And I've noticed that there seems to be a tendency, at least on my part, to underestimate the weight, and certainly there's a tendency for the patients to underestimate their weight. And by dividing by 2, you actually come up with higher kilograms, which may be more exact to the patient's true weight. The other advantage is it's a lot easier to divide by 2 than 2.2, and when you're starting out with an estimate to begin with, why try to use the more exact formula when the 2 is much easier to use? So I could think of other arguments to use. I'm just going to stop with those and get right to the problems. But as I do the problems, I'm going to be dividing by 2. If in your training class or your program you divide by 2.2, definitely use what you've been taught to do. First problem. You're responsible for providing the proper dose of etomidate to your partner so that he can initiate the RSI procedure for your patient. The patient weighs an approximate or an estimated 160 pounds. You are to draw up 0.3 milligrams per kilograms of etomidate into the appropriate syringe. How many milligrams are required? How many milliliters will you have to draw up? How many vials will be required? So etomidate comes in 20 milligram per 10 mLs vials. Let's see. Let's write down all the information that we have so far. The patient's weight is equal to 160 pounds. And I'm going to divide by 2 to get 80 kilograms. The desired dose is 0.3 milligrams per kilogram. And the concentration of the drug is 20 milligrams and 10 mLs. So let's write all that in the formula. The desired dose is 0.3 milligrams per kilogram times the patient's weight, 80 kilograms, all divided by the concentration, 20 milligrams per 10 mLs. And working that out, let's see, the 0.3 times 80, that works out to 24 milligrams. The kilograms cross off. Here we'll simplify this to get it into milligrams per ml, so this works out to be 2 milligrams per ml. I'm going to just divide it each side by 10. And so the final answer is 12 milliliters. Milligrams cross off. So we have all the answers to the questions at this point that we were asked. First, they asked how many milligrams are going to be required. That was the 24. Then they asked how many milliliters will we be supplying. That's the 12. And then they asked how many vials are going to be needed. Well, we see that each vial has 10 milliliters in it. We need 12 in total. That means we're going to need 2 vials. All right, first question, done. Let's do the next one. Now the patient is asleep, and you give your partner the syringe of the succinylcholine that you drew up based upon the patient's weight. The dose is 1.5 milligrams per kilogram. How many milligrams are required? How many milliliters did you put in the syringe? The succinylcholine comes in vials that have 200 milligrams in 10 mLs. Let's write out the problem one more time. The Patient weighs, this is the same patient, they weigh 160. So weight is equal to 160 pounds. And we're going to divide by 2. Divide by, my pen's not working here right now. Divide by 2, and that's going to equal 80 kilograms. The desired dose is 1.5 milligrams per kilograms. And the concentration is 200 milligrams in 10 mLs. Let's write out the formula. 1.5 milligrams per kilogram times the 80 kilograms, all divided by 200 milligrams per 10 mLs. Let's see, I'll do the calculation up here, the math, in case people are having trouble with the math. 1.5, 0 and 40, and then just 80, so 120, 0 and 1 decimal point. So the 1.5 times 80 kilograms is 120 milligrams. And here I'm going to divide each side by 10, so I can end up with 20 milligrams per milliliter. 20 into 120 equals 6 milliliters. So this is the amount of milliliters that we're going to draw up. 120 is the amount of milligrams of the medication that we're going to draw up. All right, next question. So if you have trouble following these calculations, I would recommend go back and look at the first video, where you can see how this, once you do the patient's weight times the desired dose that's weight-based, you end up basically a very simple formula. It's just desired dose divided by concentration. All right, question number 3. We're still working with the same patient. Now it's time for the vecuronium to be administered to the previous patient. The dose is 0.01 milligrams per kilogram. How many milligrams are required and how many mLs are in the syringe? And vecuronium comes in vials that are 10 milligrams per 10 milliliters. Okay, patient's weight, once again, is 160 pounds. Divided by 2 equals 80 kilograms. The desired dose is 0.01 milligrams per kilogram. And the concentration, we said, is 10 milligrams in 10 mLs. So let's put that in the formula. We have 0.01 milligrams per kilogram times the 80 kilograms divided by 10 milligrams per 10 mLs. I'll do the math up here. We have 80 times the 0.01, and that's just 80, and we have 2 decimal points we have to move over, so 1, 2. So that's 0.8 milligrams divided by 1 milligram per ml, which is equal to 0.8 mLs. Okay, so the dosage that we had to draw up was 0.8 milligrams, and the amount of fluid that we would draw up in the syringe is 0.8 milliliters. Next problem. And this is the last problem in this set. Let's see. All right. You have a patient in SVT refractory to adenosine. You decide to administer 0.25 milligrams per kilograms of diltiazem IV push. I'm not familiar with that medication. I'm probably mispronouncing it. And the patient weighs 130 pounds. How many milliliters will you draw up? All right. Our patient weighs, weight is 130 pounds. So that's 65 kilograms. The let's see, the desired dose, we want 0.25 milligrams per kilogram. And the concentration for this medication is 25 milligrams per 5 mLs. Putting everything into the formula, let's see, we have 0.25 milligrams per kilogram times 65 kilograms over the concentration 25 milligrams per 5 ml. Right. I'm going to move this down a little bit so I can have some room for calculations. First, 0.25 times the 65. I'll do that out. 65.25. That's 25. Carry the 2. 5 times 30. 6 times 5 is 30. And we have the additional 2. This is 10. Carry the 1. 2 times 6 is 12. That's 13. So that works out to 13.25. 13.25 milligrams. Oops. I made a mistake. This should be 16 over here. 16.25 kilograms. And then this should be 5 milligrams over 1 ml. So the last thing, I have to divide 5 into the 16.25. Five goes into 16. Oops, it is. 5 goes into 16.3. And 5 goes into 12 twice. And 5 goes into 25 5 times. So this would be equal to 3.25 milliliters, or we can just round it up, 3.3 milliliters. As one of my instructors would say, go high or go home. All right, there we go. And I just found one more problem, so I lied before. So this is, let me get this one. All right, you are resuscitating a patient who is in cardiac arrest with a rhythm of ventricular fibrillation. You are responsible for all drug administration, so your first priority is the bolus of epinephrine that you deliver. Now you need to administer 1.5 kilograms of lidocaine, as that is the only antidysarrhythmic that your service currently stocks. How many milligrams are necessary for your patient who weighs 240 pounds? How many preloaded syringes are necessary to satisfy this requirement? And the lidocaine comes in preloaded syringes that are 100 milligrams in 5 mLs. So let's write out all the information that we have. Patient's weight is 240 pounds. Divided by 2 is equal to 120 kilograms. The desired dose is 1.5 milligrams per kilogram. And the concentration, we said, was 100 milligrams in 5 mLs. So let's put all this in the formula. 1.5 milligram per kilogram times the 120 kilogram over 100 milligrams 5 ml. All right. I'm going to multiply the 1.5 times the 120. Well, I have 120 up here. I'm going to put 1.5. Let's see. That's 0, 0, 1, and 6. And then I have 0 to 1. So 180. Okay, move over 1 decimal point. So I have 180 milligrams. And if I reduce this, this becomes 20 milligrams in 5 mLs, in 1 ml. And when I divide the 20 into the 180, that's 9 milliliters. So 9 milliliters is the right amount to draw up. There was a question here about how many preloaded syringes am I going to need? Well, each preloaded syringe has 5 mLs. I need 9 in total, so I'm going to need 2 syringes. That's it for this for these weight-based calculations. The next set of calculations, I'm going to add calculate drip rates. So that'll be in video 3. Hi, my name is Kirk Fleming. I'm an EMT and paramedic student, and I also have over 30 years working as an insurance company mathematician. I thought it would be helpful if I went through some calculations, actually wrote out some of the problems for some paramedic med math calculations. And I'm going to recommend a website called Paramedic Pearls and Pitfalls. This is a website by Chris Johnson, who's a Florida paramedic, and he is also a paramedic instructor. And on this website, he has some questions, 20 questions that he gives his students, and I'm going to go and work through those problems. I've been doing that over 3 videos. The first video dealt with how much medication to draw up in a syringe. The second video dealt with calculations that involve the patient's weight. So these were weight-based medical administrations. Then finally, the last one, this one, is going to have drip set calculations. Chris talks about the master formula, which is shown here on the left side of the screen. It's desired dose times the patient weight times drip set divided by the concentration of the medication divided by the time. So you can think of that as DD times W times DS divided by C times T, which is equal to Dunkin' Donuts was dropping sugar over their coffee and tea. The advantage to this formula is you only need to know this one formula. All the problems, you just use as much of the information as you have for this formula, and then you work it out and you get your right answer. So let's start. Your patient that you've been working with has been resuscitated after a couple of rounds of drug therapy, and now you must start a lidocaine drip at 3 milligrams per minute using microdrip tubing. How many milliliters how many drops per minute are necessary if the pump fails? So let's write down what we have for this problem. The desired dose we're given is, let's see, get a pen, okay. Desired dose is 3 milligrams. And the time is, we want to do that over 1 minute. The drip set that we're using is a microdrip set, so that's 60 drops per minute, per milliliter, I'm sorry. And the concentration, lidocaine is supplied in 2 grams per 500 mLs, at least in this example. This is what we're using. And I'm going to convert that into the common dosage, or common unit of measure that we're doing the desired dose. So 2 grams is equal to 2,000 milligrams per 500, which is equal to 4 milligrams per ml. All right, so now that we have that, let's write out the information in the formula. The desired dose is 3 milligrams times 60 drops per milliliter divided by the 4 milligrams per milliliter, and that's times 1 minute. There are some things that cross off. We get the milliliters cross off, and the milligrams cross off. What we end up with is 180 drips over 4 minutes, which is equal to 37 and a half if I do the arithmetic, so 38, we round up, 38 drops per minute. And that's the answer. Let's see. Erase that one, and we'll move on to the next question. All right, let me see. You are going to be initiating a nitroglycerin drip in the field for a patient with a confirmed STEMI. You have your micro drip tubing prepared, and you are to start the drip at 15 micrograms per minute. Your patient says he weighs about 180 pounds. All right. The drug dose, the drug medication isn't weight-based, so we don't need the weight. That was just extra information in here. The desired dose is equal to 15 micrograms. The time that we're administering this is 1 minute. We're using a microdrip set, so the drop set is equal to 60 drops per minute, per milliliter. Keep saying that. The concentration, nitroglycerin in this example has 25 milligrams in 250 mLs. So converting that into the same units as the desired dose, that's 25,000 micrograms in 250 mLs, which is equal to 100 micrograms per ml. Putting that into the formula, desired dose, we have 15 micrograms times the 60 drop set per milliliter, all over the 100 micrograms per milliliter times 1 minute. Oops. Let's see. All right. Some things cross off. Micrograms. I can cross off a 10 here. I have 6 times 15 is 90 drops over 10 minutes, which is equal to 9 drops per minute. 9 is the answer on that one. All right. Next question. You're responsible for starting a diltiazem drip, I believe that's pronounced, using microdrip tubing for her 200-pound male patient who has had a heart rate control via a bolus of diltiazem several minutes ago. The protocol states that you are to mix 20 milligrams of diltiazem in a 150 ml bag of D5W and deliver it at a rate of 5 milligrams per hour. How many drips per minute would be necessary if your pumps were to fail? All right, let's write out the information that we have. Desired dose is equal to 5 milligrams. And the time, that's 5 milligrams per hour. The time here, in this case, is 60 minutes. The solution set, the drop set, is equal to 60 drops per ml. And the concentration in this case is equal to, we were told to mix 20 milligrams in 150 mLs. All right. I'm just going to do the division over here so we can get that as a, reduce it down to rate per milliliter or concentration per milliliter. I'll do the calculation here. 150 divided into 20. Okay, 150 goes 0 into 20. It goes once into 200. 0, 5. Okay. It goes 3 times into 500. And you can see this is going to be a continuing decimal, 0.15. So the concentration is 0.133 milligrams per ml. Let's put all this in the formula. We have 5 milligrams times the 60 drop set per ml divided by the 0.133 milligrams per ml times 60 minutes. 60 and the 60 cross off, the milliliters cross off, the milligrams cross off. What we end up with is 5 drops per 0.133 minutes. Okay, so that's not very helpful. We want to divide the 0.13133 into the 5. When you have a decimal point over here, let's see, we move it once, twice, and 3 times. So you're going to move this once, twice, 3 times. That's where the new decimal point goes. 133 into 500 goes 3 times. And that's 399. 0. Okay. 101. It goes 133 goes 7 times into the 1010. That's let's see. That's a 931. That's 0, 0, 9. Let's see. 3 from the 0 is 7 and 1. All right, and it goes, let's say, about 5 times. This next time, 5 times. So we're talking about 37.5 drops per minute. That's 38 drops per minute. And that's the answer in this case. Next question. All right, let me see. Okay, you're going to start a nitroglycerin drip for your patient. So you place 30 milligrams of nitroglycerin into a 100 milliliter bag and deliver it via microdrip tubing at a rate of 40 micrograms per minute. How many drops will that be? All right, so the desired dose in this case is equal to 40 micrograms. The time we're talking is 1 minute. The drop set is equal to 60. We're using microdrip tubing here in this case. And the concentration is equal to 30 milligrams per 100 mLs. That's equal to 3,000 or 30,000 micrograms per 100 mLs. Which, let's see, take off 2, that works out to 300 micrograms per ml. If we put all this in the formula, we have the desired dose is 40 micrograms times the 60 drop set divided by the let's see, we have 300 micrograms per ml times 1 minute. All right, so we can cross off some things. This is drops per ml. Okay, so we have drops per ml, get crossed off the micrograms, get crossed off. I can cross off a 0 here, a 0 here. I'm ending up with 24 drops over 3 minutes, which is equal to 8 drops per minute. That's the final answer. All right, one more problem and then that'll be it. You have a patient who is suffering from a severe hypertensive emergency, and you are ordered by medical control to deliver 20 milligrams of labetalol over 2 minutes via IV push. You are then to administer 2 milligrams per minute afterwards to achieve a blood pressure that is reduced by 30% over where it started. You routinely mix your labetalol infusions by adding 100 milligrams to a 150 milliliter bag using a 10-drop tubing. How many drops per minute does that equate to? All right, so there was two separate issues here, you gave an initial infusion of 20 milligrams over 2 minutes via IV push, but then we get into the drip set calculation. And we're saying the desired dose is equal to 2 milligrams, and the time over which we want to do that is 1 minute. And the drip set we're using in this case is 10 drops. This is a macro set per milliliter. And the concentration, we're told, is we add 100 milligrams into 150 milliliters. 150 milliliters. All right, which works out to 0.66 milligrams per ml. This is 2/3. 100 is 2/3 of the 150 in this example. To me, if you had your choice, it would probably make sense to mix 100 milligrams and 100 mLs so that you don't end up with these weird numbers. But that's what the problem is. So to put all this into the problem, we're mixing 2 milligrams times the 10 drops per milliliter drop set, and that's divided by the 0.66 milligram per ml concentration times 1 minute. All right. So this is 20 drops. Right, these cross off. This cross off. Divided by 0.66 minutes, which, if you do the division, works out to 30 drops per minute. All right. Yeah, I would think, being a student, I'm not there yet, but I would think it would make sense when you mix your medications into the bags that you would mix like units just to do yourself a favor as far as the calculations go. I don't know what people practically do, but that's what I'm going to try to do. The last item, I lied, I have one more question. You are underway on a long transport and have been ordered to add 1 amp of phenytonin to a 150 milliliter bag of saline, which is to be run over 1 hour. How many drops per minute are you required to run? All right. Phenytonin. Let's see. This sounds a little different than the other ones, but this is exactly the same. And if you just follow the calculations through blindly, you'll automatically you'll get the right answer. Let's see. The desired dose is 1 amp, and the time we're going to do this over 1 hour. This is 60 minutes. And the drop set is equal to, I'm going to make this a macro drop set, drops per milliliter. And finally, the concentration is equal to 1 amp per 150 ml. So let's write that out in the formula. We have 1 amp times the 10 drop set per milliliter divided by the concentration. That's 1 amp per 150 ml times 60 minutes. All right, so the milliliters cross off, the 1 amp crosses off. Let's see, we can take out a 10 here. So when I do the division, when you have this double division, that actually works out to 150 drips over 6 minutes. And that works out to 25 drips per minute. So that's it. Those are all the calculations I have. I hope this was helpful to you, and you guys have fun out there and good luck.